Good morning, everyone, and welcome to this first webinar for the GREENHOOD project. So in this first session that we have organized, our main goal will be to present and to introduce our webinar. I am Teresa Ridolfi from Trust IT Services. We are leading the dissemination and communication task of GREENHOOD. And today, as I was saying, we will have a first introduction of the project, introducing also the 4 demo regions of GREENHOOD, and also giving an overview of the main activities that we will provide during this project. So first of all, let me share my screen to give you a brief overview of the of our speakers. So we will have the coordinator of the GREENHOOD project, the Beta Technological Center, today represented by Laia Lienas Arjalaget, that will briefly introduce the GREENHOOD project and the main goals. Then we will have a round table together with all the demo region coordinators from the 4 different demo regions. And after that, we will have a brief Q&A session for any eventual questions that you might have and that you can ask directly to the panelists. So my presentation will stop now. I will leave the floor to Laia Lienas Arjalaget from the Beta Technological Center from the University of Vic for a first introduction of the GREENHOOD project.
Thank you very much, Teresa, for the introduction. Can you see my screen? Perfect. So good morning, everyone. Thank you very much for all those that have joined this webinar to know a little bit more about the GREENHOOD project. GREENHOOD project is titled Nutrient Balance and Resource Optimization in Regional Ecosystems through Holistic, Sustainable and Zero Pollution Solution. And it's coordinated by Beta Technological Center by my colleague Mabel Mora. But today I'm representing the coordinator, so I will give you this overview of the project. So this project started last January, and it will last for 4 years. It was funded by an Horizon Europe topic in Cluster 6, and it have a budget of more than 9 million euros. And we are 31 partners from 10 different countries, so we have a broad representation across Europe. And here in this slide, there's a little bit the context of the project and why GREENHOOD has been planned and started. So the main goal that GREENHOOD is looking for is to help balancing emissions from nitrogen and phosphorus-based fertilizers in agriculture, helping also to enhance the soil health, reducing eutrophication and water pollution, and also limit harmful emissions to the air. So we will do that demonstrating single or integrated region-specific practice in all relevant NP sectors. So you will see that we have practices in each of the regions, and in each of the regions we are covering different sectors. So this way we are covering a broad, we are proposing a very broad approach. We will be testing different innovative practices and technologies to make use of secondary raw materials and produce bio-based fertilizers recovered from organic waste, wastewater, biological residues, or byproducts, and promote local and regional value chains. And the other relevant part of GREENHOOD is all related to governance models. So the different European projects give usually policy recommendations, but GREENHOOD, we want to go a step beyond, and we want to promote a series of best practice incentives and guidelines in each of the demonstration sites. So in that sense, we will be working very close to the public authorities in each of the regions and be able to apply new governance approaches and solutions, tackling the challenges of the different places.
Laia, sorry to interrupt you.
Yes.
I'm not sure if you are scrolling the slides, but
yes,
we are still seeing the first one. So maybe if you want, we can share the slides for you.
I'm moving the slides. You cannot see it, eh?
No, they are stuck. I can share them for you. 1 second.
Sorry, because before it worked.
1 second.
I can try to share again, if you want. It's just
No. I think it's easier if we do share them.
Okay.
1 second. Okay. Okay, can you see my screen?
Yes.
Okay, I'm
So
not
I
sure.
think you can go directly to this one. Yes.
Okay, to the number 6. Okay.
Yes.
Okay, please go ahead. Sorry to interrupt you.
No. I'm sorry that it didn't work. Okay, so well, having set a little bit the context of the project, so this is the main objective that we have. So the main objective of GREENHOOD is to demonstrate an effective approach to rebalance nutrient flows and reduce NP emissions through targeted efforts in regional hotspots. No, so we will work first of all on defining which is the context in each region to detect which are those hotspots, and then to see which are those solutions that can fit better with the needs of each region. No, so at the end we will be providing different targeted solutions, and this will be guided also by nutrient budgeting methodologies and a collaborative approach with regional stakeholders. Okay, so here you have a little bit also a scheme of our methodology, no? So we will have a block working on monitoring on modeling, this regional co-definition, and then the optimized methodologies for, at the end, help on rebalancing the nutrient flows and obtain governance models fitting the needs of each of the regions. So if you can go to the next slide, please, Teresa. Yes. So these are the 4 pillars that we have defined for the project methodology. So as I was saying, no, we will the first pillar will be establishing the basis in each region. So we will be through stakeholder involvement, codifying the different transition pathways and optimize nutrient budgeting methodologies. Through the advanced nutrient models. Then we will have a second pillar working on demonstration, different balancing techniques. So here we will have, as you will see in the different demos, different technologies, different strategies, nature-based solutions, etc. Then the pillar 3 will be focused on governance and the regulatory aspects. And the 4th, of course, about the dissemination, communication, and exploitation. Next slide, please. So these are the 4 demo regions that we have, and that you will hear about the 4 of them in the following presentations. So I will not go into detail, but this way I can give you the overview of the 4 of them before going through the 4 presentations. So Teresa, if you want to move to the next one, and that will be my last slide to give you a little bit which are the main results that we expect to obtain in GREENHOOD. So these results, on the one hand, we will have the optimized regional nutrient budget. So for that, we will be performing this regional stock taking analysis to see the starting point. Then we will define pathways for implementation of the different solutions and the optimized nutrient models that will also help on this nutrient balancing. Second block is this nutrient balancing practices targeting the different sectors that will be targeted in the different regions. In this case, we will be demonstrating different technologies to recover nutrients and produce bio-based fertilizers. We will also work on different nature-based solutions to mitigate nutrient losses and reduce nutrient pollution. We will be working on different regional circular pathways, and also the sustainability assessment of the different solutions. And finally, we will have all this block related to governance and business models. So we will be providing specialized policy recommendations for each region, the solution feasibility and economic analysis of what we are proposing. We will also work on regional upscaling plans. And finally, we will also work on funding and financial strategies to implement the solutions that the project is proposing. And that's all from my side, just to give you an overview of what the GREENHOOD project will be working with during the next 4 years. And I think that now it's nice that you can hear about what will be done in each of the regions. So Teresa, I don't know if each demo region is sharing the screen, or you do that for everyone.
So yes, now, thank you, Laia. First of all, now we will have the first presentation of Demo Region 1, which is the Ebro River Basin, so based in Spain. At this point, I can also continue sharing my slides since I have the ones from Anna, if you agree, Anna.
Yes.
So this presentation will be presented by Ana Robles Aguilar from the Beta Technological Center. Before you start, Anna, I just wanted to remember to our audience that if you do have any questions, you can already start, let's say, typing them in the chat or also in the Q&A box, and we will try to reply to all of them during our session. So please, Anna, the floor is yours.
Okay, thank you very much. And I will be introducing you today the demo from the Ebro Basin and all the different practices that we will be implementing in our demo. So to start, some general information about our demo. We are in the Ebro Basin, and this represents two big areas. It's Catalonia, but also the Aragon region. And our demo will showcase various solutions and different strategies. So it will not be a demo confined in a single location, but we will have instead solutions that will be positioned in a designated area, primarily covering these two locations in Catalonia. And there we will test our main goals, that is the mitigation of nitrogen and phosphorus emissions in three key sectors, named as agriculture, wastewater treatment plants, and the groundwater that has been contaminated. So the different flows that we'll be assessing that has high nutrient content would be manure, but also the organic reduction of municipal solid waste, wastewater treatment plant effluent, sewage sludge, and nitrate polluted groundwater. So to put you a bit in context why this could be our main goal, our region with Catalonia mainly, but also Aragon, it's a region with very high intensive livestock production and also a very well implemented and successful agro-industrial sector. So in Catalonia, for instance, almost 40% of our territory falls into the nitrate vulnerable zone, as you can see there in the map. This is a big problem, and this is what has motivated us to implement the different solutions that I will show you in a minute. So if we go to the next slide, Teresa, just before presenting you the solutions, the partners that I want to introduce you, the partners that we will work together to try to reach our goal. So we have research centers and technological centers, but also in our demo, we count with different companies and different government partners that are also involved in our demo that will help us to support in the implementation of the solutions. So now moving on to the solutions. Here I want to give you an overview of the different rebalanced nutrient budget practices, and those cover four main solutions. The first one will be the advanced environmental technologies for nutrient recovery from digestate after anaerobic digestion. The second one will be the bioremediation of nitrate polluted groundwater. The third one will be the assessment of that for urban wastewater effluent treatment, and then the smart fertilization and fertigation, including having the application of tailor-made fertilizers and bio-based fertilizers. So what we will get from all of these solutions will be the production of bioenergy and reclaimed water, and also the production of bio-based and tailor-made fertilizers. So I will go now one by one a bit more in detail. So in the next slide, we start with the advanced environmental technologies for nutrient recovery from high-value digestates. So the digestate will be transformed into different valuable resources. So starting from the beginning, we have the different feedstocks that you can see here in the screen and in the square. And then from the manure or the solid waste, sludge, or the agricultural waste, all of these feedstocks will go into the anaerobic digester. And there we will produce first biogas, where we will have the biogas upgrading for the biomethane, for the production of energy, and also CO2 production that can go to help in the production of the cultivation of the microalgae. And from the digestate, that also come as a byproduct for the anaerobic digestion, we have the implementation of a solid liquid separation unit. And from the liquid fraction, we will have two approaches. First, we will have for the electrocoagulation for the phosphorus recovery, and also membrane distillation for nitrogen recovery. And then from the solid fraction, we will focus on advanced composting, where we will have low emission compost. And then if you press the next there, so from here we have, there. Yes, so we have already, as you can see with the green check, we have already some of these technologies already in place or available, let's say, like the anaerobic digester is already, the solid liquid separation unit, and also the membrane, and the biogas upgrading facility. So the rest that you can see in the schema will also be implemented during the project. And a bit more details on where is this first phase. So in the next slide, you can see that this pilot, this part of this first solution, will be implemented in Torre Santa Maria farm. And yes, the Torre Santa Maria it's a cow farm. We produce a lot of cow manure and around 20,000 tons of agro residues. So here you can see pictures of how the farm look like, and then also the membrane distillator unit that it's also available for the nitrogen recovery. And next slide, Teresa. Here it's our second solution that I already mentioned. It's the bioremediation of groundwater that it's contaminated for some of the in the aquifers. So here you can see a picture of the aquifer location, and the proposed strategy will be biostimulation. So we will have in situ the nitrification done with the microorganism. Yes, we can give more details, but basically this is one of the solutions for the aquifers, and then the third one will be different nature-based solutions to mitigate nitrogen and phosphorus pollution from wastewater. This is located in a different area in Balaguer, where the wastewater treatment plant is. You can see here in the map, and then this will be to reduce the MP loads before the water enters the rivers. In the next slide, Teresa, you can see better how it will look like. So this will be the place next to the wastewater treatment plant where this nature-based solutions pilot will be installed. It will look like some similar like this picture that you see here in the middle. And then the natural organisms that are planned to be used are the lemma, that it's a microphyte, a floating microphyte, and then we will also use some other microphytes that are also adapted not to high nutrient loads, and the natural growing microorganism, microbial community that will be grown. And our last solution, if we go to the next slide, it's the smart fertilization and fertigation, including the formulation of both bio-based and tailor-made fertilizers. So in the surrounding areas of Torre Santa Maria, there is already some farmlands where they cultivate different crops like corn or alfalfa. So this area next to Torre Santa Maria, it's an irrigated area from one of the canals near the farm. And this will be the place where we will be testing some of the products that are recovered there in the same farm that I already introduced you in the first solution. So you can see there are some fields. This one marked there, we are already using to test some products in another project, but that are not as refined yet as what we intended to get here in the GREENHOOD project. Yes, so the main goal will be to formulate different tailor-made fertilizers from both the solid fraction and the liquid fraction of the digestate, and we intended to test them in maize or different cereals. And of course, we will adapt the experimental design to include products that are suitable maybe first for bottom fertilization and later on for top fertilization, depending on the nutrient content of the plant needs. And then as another approach that we will have, it's the development of a fertigation system that can be adapted to use either the reclaimed water or the liquid fraction that has been treated already, where the main of the nutrients has been recovered, but that can be also applied to the plant as together with the water and the fertilizers that the plant needs. And this might be adapted with the software that can manage the nutrients that we have in this liquid fraction or in the reclaimed water. So all of these four are the main solutions that we will be testing. And yeah, with this, I hope I give a clear overview of our basin. Thank you.
Thanks a lot, Anna, for your presentation. So at this point, I think we can switch to our second demo region, the Rhine-Meuse and the Scheldt River Basin, presented by Stefan Jansen from Deltares. This demo region is actually covering two different countries, the Netherlands and Belgium. So Stefan, please, the floor is yours. I can continue share the slides for you if you want.
Yes, it's okay. Thank you very much, Teresa. As Teresa said, I will present the plans actually from partners from two countries, Belgium and the Netherlands, who will address a system which focuses on three rivers, the Rhine, the Meuse and the Scheldt River. And I will start by looking at these river systems, which is shown in the next slide. So here you see the river basins of these three rivers. You can see also that they span a variety of countries, actually not only Netherlands and Belgium. But we will focus on three demo locations, two in the Netherlands and one in Belgium, where we will look at the effectiveness of mainly nature-based solutions. And I will go a bit further into that in the next slide. So the philosophy of nature-based solutions is like is shown a little bit in the pictures to enhance or re-establish the natural filter function of the landscape and the soil. And in that way, we want to address the mainly diffuse emissions, which is a large topic in these regions, of nutrients coming from different sources like manure, fertilizer, or even natural background. And what you see in history is that a lot of point sources have been addressed, but mainly these diffuse emissions are very persistent source, which still has to be addressed to reach goals in the surface water. Next slide, please. So this gives some context of the region and the challenges we are facing. So the regions, especially the Netherlands and Belgium, have a lot of intensive livestock production and agro-industrial sector, and these lead to nutrient emissions, mainly nitrate and phosphate. And these lead to surface water quality issues, a lot like what Anna showed also for the Ebro case, which is quite similar, I think. Also here, large part of, actually almost all of the territories designated as nitrate vulnerable zone. And in the figures you can see, well, the top figure shows the example for Belgium, where nitrate levels are high in a lot of cases. And also in the graph below, you can see that in a lot of cases for the Luikbeek, one of the demo locations, concentrations are often above standard. So something has to be done, and it's quite well known and also accepted that a shared effort is needed from various stakeholders, that we also try to also work together with in this project, like water authorities, farmers, landowners, nature organizations, etc. Next slide, please. So what we try to test is the solutions towards mitigation of NMP emissions in the key sectors, not only agriculture, by the way, but also wastewater treatment plants and coming from groundwater. And below you can see a couple of these measures that we want to address. So different forms of nature-based solutions, actually. And what's also interesting about these is the main effect, of course, is reduced NMP losses. But also, one advantage of these solutions is that they can also have other beneficial effects like water conservation, carbon sequestration, biodiversity effects, and possibility of reuse of sediment and biomass. So we will also look at these additional benefits. Next slide, please. And apart from these benefits, so why would you look at nature-based solutions? They have a couple of benefits, actually. One very important one is that there's very little impact on the activities of the farmer, which makes it easier to accept these measures. You can see that a lot of them have quite effective removal of nutrients. One of the questions, though, is in practice, how much effectiveness will we reach? And as I mentioned before, there's a couple of additional benefits, which makes acceptance also better. Fourth benefit is that in many cases, little space is needed because you could use surface water or soil. So then it's also easier to fit into the landscape. So there are a couple of questions still. How effective are these measures? Also, what are the side effects? Not only the positive side effects, but also negative side effects. You can think of greenhouse gas emissions, water effects. These have to be addressed. And last but not least, these solutions have to be robust. And also they have to be accepted and practically applicable. And all these factors we will try to test in the field, not only to give direct information, but also experience and confidence. Next slide, please. So now I will show some examples of these nature-based solutions that we're going to test. First, a couple of examples that we are thinking of for the Netherlands. Here you can see some pictures. One of them is the left top picture, where you could think of a vegetated buffer strip. This is a picture which is related to some examples from Denmark. If you could create a buffer strip alongside the ditch where water coming from the agricultural field passes through a sort of filter system with vegetation, then you could achieve reduction of nutrients and also biodiversity and water conservation goals. A second example, which is quite similar to this, is two-stage ditch, where you can go from a traditional channel, which is quite narrow, to a more broad channel where the water can actually flow and also stay for a longer time, so that you can also use sedimentation effects. And that also relates to the sedimentation ponds, where you can actually create ponds where especially the overflow water can sediment, and particles with a lot of phosphorus in it, for instance, can sediment. Next slide, please. Last example, which is already in place, is a wood chip bioreactor, which you can see in the photo below, which is a way of enhancing nitrate removal by adding organic matter, which can help the naturally occurring microorganisms to degrade nitrate into nitrogen gas. And in the picture in the right, you can see one of the field areas where we are going to test a couple of these measures. The wood chip reactor is already in place, but you can also see that we can test in this small region together with farmers and water authorities a couple of these measures, which makes it really interesting to together with stakeholders to actually also see how things work. Next slide, please. Then to an example of the type of solutions that will be tested in Belgium, which will address more integrated constructed wetlands at river catchment level. So this is a green solution which uses mainly plants, but also sediment processes to remove nutrients. And in this picture, you can see that, well, the idea is already known, but one of the questions is how you could give form to this in a river system. Where do you find space to put these plants and to create an optimal movement of water through the system? And this will actually be tested also in practice. So the next slide shows an example of an idea of one of these demo cases in Belgium, the Luikbeek area, where plots of lands are designated to create wetlands and to also test effects and optimal use. Next slide, please. And then, well, next to this testing in the field, the idea is also to upscale the effects of nature-based solutions, which is actually a link to another work package in the GREENHOOD project, because in the end, we want to know how much these nature-based solutions actually contribute to reaching certain goals. So from the field test, we will take numbers which can feed into the Marina model, where people from Wageningen University are working on. And that enables us to actually estimate whether we can go from an actual pollution level towards a reduction towards certain targets, and whether we actually can reach these targets. So next slide, please, which is actually the end of my presentation. I'm really looking forward in this project to learn together from practice, and also, well, to make the link with the other demo regions, where we can learn a lot of things from different cases. So thank you.
Thanks a lot, Stefan, for your presentation. So we are now moving north, let's say, to our next demo region, our third demo region, the Archipelago Sea Basin demo region, which is actually presented by Kari Livano from the Natural Researches Institute of Finland. If you want, Kari, I can continue sharing the slides for you. So please, the floor is yours.
Okay, thank you, Teresa. So I will present this demo, this Finnish demo regions, which is this Archipelago Sea Basin. And from the map, you can see that it's located in southwest part of Finland, and the biggest city in this region is Turku. So we are presenting solutions for mitigating both nitrogen and phosphorus emissions from the key sectors, agriculture, forestry, and wastewater treatment plants. And nutrient-containing flows assessed in the demo includes this agricultural nutrient loading, including manure, which is the most important one, and then sewage sludge and nutrient loading from forestry. As you know, in Finland, roughly 75% of our land area is covered by forestry. So the next slide. As a background, this Archipelago Sea, it's a shallow sea basin, and there's over 40,000 islands, and it has a high retention of waters collected from several river catchments. And this basin, it's vulnerable to nutrient loading, and it's the only hotspots of the Baltic Marine Environment Protection Commission in Finland. At the moment, the state of the basin is mostly moderate, and the main problem is eutrophication and diffuse nutrient loading. In this catchment area, it has an intense agriculture, a total of 240,000 hectares, which covers 28% of the land area. Most of the farms, they are crop farms. About 80% of farms are producing crops and other plants, but they also livestock production, mainly pigs and poultry, and those farms, they are regionally concentrated in the western part of the region. And the soils also in this area, they are mainly clay soils, so they are very high risks for erosion. And also because of the previous agricultural practices and also the livestock production, soils have such a high phosphorus status that no yield responses with pea fertilization is rarely achieved. So the manure produced in this region could cover the region's phosphorus fertilization need, but there's a requirement that it should be reallocated from surplus areas to deficit regions. But of course, this would require processing, but there's still quite a little of processing conducted at the moment. And from these maps, you can see that there are municipalities having higher soil phosphorus status, whereas in neighboring regions or municipalities can have a lower. So in a proper distribution of these manure-based nutrients, these problems could be making smaller. As I said, the main land use on this region is also forestry, and there are some nutrient losses originating from forestry as well. So there needs to be some activities to reduce those nutrient losses as well. In this region, as well as in the whole Finland, most of the sewage sludges are anaerobically digested, followed by separation to solid and liquid fraction. Most of the phosphorus end up, or almost all end up to this solid fraction. But in this liquid fraction, it contains a lot of nitrogen, but there's a need of processing this liquid fraction in order to make it better nitrogen fertilizer. So next slide. So we are proposing following things that we could do in order to rebalance nutrient budgets. We are testing soil amendments which have been shown to be efficient in reducing nutrient losses through erosion. And here we are testing gypsum, which is a byproduct of when producing phosphorus fertilizers, lime, as well as then fibers, which are byproducts from forest industry. Then processing the liquid fraction of this digested sewage sludge in order to improve its nitrogen fertilization efficiency. Producing tailor-made fertilizers from poultry manure, and especially in order to improve this nitrogen phosphorus ratio in order to better meet the crop demand. And also we are evaluating this nutrient recycling subsidy in order for regional reallocation of phosphorus. Next slide. So the overarching approach in our demo is to remove the hotspot status of the archipelago sea basin. And all these measures that we are now suggesting are based on this National Archipelago Sea Program that was established in 2021. And it includes also a close collaboration with authorities, including Ministry of the Environment, Ministry of the Agriculture and Forestry, regional authorities, as well as farmers associations. And we are conducting a close collaboration with ongoing national and international projects. And there's an example of this AINE project, which is a national project where we are testing these, actually these soil improvers. They have been already spread on farmers' field last autumn, and they have been spread over 800 hectares. And now we are following how they will affect on soil quality that is coming from these fields. And when we are producing these bio-based fertilizers, these nitrogen fertilizers from sewage sludge, as well as these tailor-made fertilizers from poultry manure, we are testing those in a field and laboratory scale. And of course, from the farmer's point of view, this agronomic efficiency is really important aspect. So this will be tested, but also these potential nutrient losses will be evaluated as well. And so this, as I said, this nutrient recycling subsidy, it will be evaluated how efficiently it can potentially redistribute phosphorus. Next page. So in Finland, we have a total of 5 partners. Luke is leading this demo. So we are quantifying and modeling of nutrient flows and balances. We are assessing of policy measures, and we are conducting this experimental work related to soil improvers and bio-based fertilizers. And all partners will participate on communication and dissemination activities. Then this local authority, Center for Economic Development, Transport and Environment, have a direct link to the measures in the National Archipelago Sea Program. And they are arranging a phosphorus status clinic with farmers and support for nutrient recycling solution and policy measures. And then MTK, Varsinais-Suomi, it's a local farmers union, and they are supporting for promoting nutrient recycling solution and policy measures in agriculture and forestry of this demo region. And then Finnish Biocycle and Biogas Association supports for bio-based fertilizer production and nutrient recycling measures. And then Fertilex, it's a company producing recycled fertilizers, and they are developing these pelletized bio-based fertilizers from poultry manure in order to improve its nutrient ratios. And they are conducting also this experimental work. And in addition to these partners, also we have Kasum and Kiertoravinne. They are subcontracted by Luke, and they are participating to bio-based fertilizer production, especially these nitrogen fertilizers from sewage sludge. And they are also taking part in this experimental work. Thank you. This is all.
Thanks a lot, Kari, for your presentation. Now I leave the floor to our last demo region, the 4th demo region from the Trondheim Fjord Basin in Norway, that will be represented by Daniel Müller from the Norwegian University of Science and Technology. So Daniel, I will leave the floor to you if you can share your screen with your slides. Thanks.
Okay. Trondheim Fjord Basin. The Trondheim Fjord is in the middle of Norway, as you can see here. And the Trondheim Fjord is actually almost identical with the Trøndelag County, except that we have a lot of waterfront in addition as well. We have a main demo location at Svanem biogas plant. And the main purpose of this demonstrator is to identify mitigation strategies for nitrogen and phosphorus for the 2 sectors that we have, which is not only agriculture, which is dominant in all of the other demo regions, but in addition, we have actually also a very large aquaculture sector in this region. So Norway produces about 50% of the global Atlantic salmon. And this is, of course, leading to a lot of emissions from the salmon production, which we are addressing in addition. So I illustrate here with this demonstration here with this figure, the phosphorus cycle in Norway. So you see that we have in Norway two big cycles. One is a terrestrial, the green one here, where we have the soil receiving mineral fertilizers that are imported, and then we have crop production, animal feed, and then animal manure going back to the soil. And we have an accumulation of about 11.5 kiloton of phosphorus. So massive accumulation here. And the reason that we have such a big accumulation is similar like in the other cases, that we have some regions that have a surplus and others have a deficit. That's why we still need mineral fertilizers. On the other side, we have a large phosphorus cycle on the aquatic side, with the aquaculture being the big driver here. Aquaculture receives a lot of feed ingredients that are imported. Salmon is actually a carnivore, but we import a lot of plant-based biomass, mainly soy from Brazil. And since the salmon cannot digest the phosphorus in these plant ingredients, we need to, in addition, add phosphorus in the form of micro ingredients that are also adding to the phosphorus surplus here, leading to a very large surplus in fish sludge that is mainly entering the water. Only a small fraction is collected and going back to the soil. Then we have, of course, fishery is a big issue here that is then extracted, but still we have a net increase in phosphorus in the water system. So the phosphorus throughput in aquaculture has become actually larger than the one in agriculture. And what is important to know is that there are efforts to increase aquaculture production by a factor of 3 by 2050. So this means if these plans that the industry and the government have are manifesting, the aquaculture will be completely dominating the phosphorus and in general the nutrient cycles in Norway. And at the same time, we still depend on a lot of imports of phosphorus in the form of fertilizer and feed ingredients. And this leads to a highly inefficient system as we have it now, with large losses that lead to accumulation in water and soil systems, and of course risks to eutrophication and also food security in terms of the phosphorus as a limited resource. So there is a need and also potential for establishing a more circular nutrient management system in Norway by recovering fish sludge and manure in more effective ways and turning them into different products. What we are analyzing here is mainly fertilizer production, that we try to use these resources for fertilizer production. So what we show here in the slide below is we have, of course, all of the aquaculture activities are along the coastline of Norway. And in addition, the coastline tends to be very hilly. And since it is very hilly, it is actually more suitable for livestock production, which is also very large there. So far, only about 2 to 3% of the fish sludge is collected, and we have plans to triple the fish production, leading, of course, to a much more critical system if we don't take drastic measurements. So the solution that we have, that we envision here has several approaches. One is that we try to establish novel technologies and novel supply chains for bio-based fertilizers. So we have different companies involved here that I will present later. And the second part is that we are testing these bio-based fertilizers in agriculture with farmers. And we are developing a digital infrastructure that will allow for a much more efficient nutrient monitoring and also for developing scenarios and analyzing what would happen if we upscale different ideas that are presented that we are elaborating here. And we do this then, of course, also together with different stakeholders. We have stakeholders from national level, from regional level, and also local stakeholders that we are including here. Yeah. So here I illustrate a little bit the technological approach. We have on top essentially three types of waste that we are interested. It is the manure from agriculture, it is the fish sludge from the fish farming, and then from the slaughter we have also slaughter waste, and it is mainly the liquid slaughter waste that is actually a concern here. Where we need also new solutions. And this is integrated in this system here. So we have a biogas plant that is then producing a liquid and a solid residue. And they can be used directly. But this is probably not a good strategy because they contain a lot of water. And this is not solving the problem that we need to transport these nutrient surpluses to regions that actually have a demand. So we need alternative strategies, and one is to extract struvite directly from the biogas plant and test this one. Then another approach is with the liquid residue that a company called N2 Applied is testing here through a plasma technology, binding nitrogen from the air and integrating this nitrogen in the fertilizer products, in the liquid fertilizer products, to better balance the nutrient composition and also to make sure that the nitrogen losses afterwards are actually massively reduced. Then with the solid residues of the biogas plant, we go into a drying process that Waster is operating. And Waster is in addition also testing fish sludge that is coming directly from a wastewater treatment plant, Xylem. They also developed drying technologies. So Waster is producing a granulate that is tested, and then we go a step further to look into further processing. So Proman is analyzing together with the TU Vienna an additional route where this granulate is then gasified. The gasification is producing a syngas consisting of hydrogen and carbon monoxide as a byproduct, and an ash. And this ash can be further processed into a calcium phosphate, which is a resource that fertilizer producers, mineral fertilizer producers, could use directly in their production chain. So these are the main four processing routes that we are analyzing. All of these bio-based fertilizers are tested subsequently in field tests with NUASEC in the lead in collaboration with the agricultural consulting services. And finally, we are then upscaling this at the local, regional scale to analyze in how far we can actually reach the goals. So here are the partners involved, NTNU, with the support of NMBU, the Norwegian University of Life Sciences, are leading the demo. We are mainly focusing on optimizing nutrient budgets, but also looking how to quantify and optimize the different individual supply chains. Then NURSEC, together with the Norwegian Agricultural Extension Services, are leading then these new government models and conduct field tests and also testing applications of the BBFs. NC Aquatech is and are FI. There are different clusters that are actually working together, and they are leading the co-definition of the basin, and they are also leading the communication activities and outreach activities within our demo. Then Svanem Biogas is our biogas plant that is participating. Then we have Xylem, wastewater treatment technology developing company. They are operating a lot of sludge wastewater treatment options, and that are then we are collaborating as an associate partner. Waster is the technology partner and developing a highly energy efficient drying technology. And then Proman, together with the TU Vienna, are testing options for gasification and the granulate, also from the granulate and then phosphate production. And finally, N2 Applied with this plasma technology, and then including the nitrogen in the fertilizer to reduce ammonia and greenhouse gas emissions. So this is a picture of the partners that we have, the Trøndelag demo participants in the kickoff meeting, and then the different technology partners that are participating in our demo. And with this, I end my presentation and thank you for your attention.
Thank you, everyone. So really exciting years ahead. We are really happy to have kicked off this project in January, and we look forward to the new developments. I saw that there were some interaction in the chat, many questions, and there is actually one, since the time is tight, I will straightforward go to the one in the box. And there is a question for Stefan, asking about the relationship with farmers. So I can imagine farmers are not really keen on losing part of their land for the implementation of this nature-based solution, seeing that this will take up a lot of space. How will you address this? Will farmers be consulted in the process? So Stefan, if you would like to take over this question, please.
So, because it's a really good question, because it's, in my point of view, well, effectiveness is actually not one of the most important issues, but it's aspects like the person who asked this question, like space needed or other aspects that farmers are finding important. So we are addressing that by involving the farmers. We're talking a lot with them, and I really like that, because you see there are several things. For instance, in that way, farmers actually come up with their own ideas. For instance, we had a farmer who had an idea of a ditch he was not using, and this space we could use for a nature-based solution. That's the example where actually a farmer can come up with their own ideas we didn't think of before. The other answer to this question is that part of solutions, we try to look for space in the soil or in the water system, which does not have to sacrifice too much of the land of the farmers. And well, the last part is also the realistic part. In the end of the project, I hope that we can also find realistic answers to the space actually needed for these solutions. And sometimes you will find out that in a certain area it will be difficult to use certain types of solutions, and then you have to go to the whole toolbox of different solutions and find the right combination of measures. So that's my point of view. But to be really short, the involvement of the agricultural sector in this is really important.
Thank you so much, Stefan. I hope this answered the question. I don't know if someone else from the panelists would like to say something in addition. That's right. Thank you all. So I think we can wrap up this webinar. Thanks again to all the panelists, everyone that joined us for this webinar. In just one moment, you will see a QR code. So we would like to invite everyone that is interested in learning more about the different demo region, in being updated on the activities and all the developments that each demo region will experience in the upcoming years. So we set up on our website a stakeholders web form. There you can subscribe to our newsletter, and you will be contacted by us in case of updates for each demo region. And yes, one second. Thank you so much, Teresa. And just to wrap up, please don't forget to follow us on our social media. You can also subscribe to our newsletter and join as well our YouTube channel. We have many exciting updates coming up, so we would love to have you within our community. So thank you again to everyone, and let's keep in touch. Thank you.
Thank you. Bye.
Thanks.
Thank you.
Bye.